Okay, we're going to go ahead and cover Chapter 6, Data, Business Intelligence. You have your learning outcomes. You need to go ahead and review them. All right, so transactional and analytical, transactional and analytical information. So we need to go ahead and know the different types of information there is. Transactional information is within a single business process or unit of work, and its primary purpose is to support the daily operations of a business. Analytical information is all about supporting how managers do their work, their managerial analysis that they have to do. How are they analyzing the numbers? How are they analyzing the return on investment? Are they meeting their quota? Is their team meeting their quota? Are they meeting their numbers? Because in the end, you all know that any business is about the return on investment and if you're able to meet the quota assigned. Information quality, the characteristics of high quality information. As you can see there's accurate, complete, consistent, unique, and timely. So we have to make sure that every information that we receive has the ability to be able to help us do our business. So the information, as far as the accuracy, it has to have the correct dollar amount. It can't be off by a couple cents. It can't be off by a couple million. It has to be accurate, on demand at that very point in time when you need it. You have to have complete data, the complete value. So when you're inputting data into a system, for instance, when you're booking a flight, you can't book a flight without saying, is the person male or female? You can't book a flight without saying the first and last name of the person. Nor can you book a flight without saying exactly where that person is going. If you don't have the complete information, you're not able to have good quality. As far as consistency, you have to make sure that everything is the same no matter what, no matter how many people are filling out that form, or no matter how many people are trying to buy a ticket. They still have to fill out the exact same fields in order to be able to buy an airline ticket. Understanding the cost of using low quality information. Low quality information is when you're not meeting the standards, you're not following the format set, you are not using your full name, you're abbreviating your name, you're using something like, instead of saying Andrew Johnson, you say AJ. Instead of saying your first and last name, you just use your first name. You're not giving full information like you should. So that's technically low quality information. And the problem with low quality information is that it costs business money. And it costs them money because they're not able to truly track the customers. They're not able to see who their valuable customers are, if their customers were their customers before, or if these are customers that are no longer relevant. So all that can lead to a company not being able to stay in business for a long period of time. Hence the relational database. As far as information is concerned, we all know information is everywhere, but in order to be able to collect the information and turn it into data, you have to be able to have somewhere to store it. Therefore, there are databases. Within the databases, that allows you to maintain different types of information. And here it shows you under database, it says maintains information about various types of objects. The object can be the inventory. The event itself can be whatever the transaction is. And the people can be the employees that work for the company. And also the places in which these things occur could be considered the warehouses. That's a nice, interesting take on databases. As far as database management systems are concerned, everyone has a database management system. And when I say everyone, I mean every single company, small and large, because that allows you to be able to say, who is my customer? What is my customer name? Where is my customer located? What does my customer buy? Do I know why my customer buys this? Do I know when my customer likes to buy this? Do I know what other products I can sell to my customer based off of my customer's last purchase? All these things can be stored in a relational database. As far as storing information into the relational database, you have different areas. You have the data element, which is the smallest or basic unit of information. You have the data model, which is the logical data structures that detail the relationships among data elements using graphics or pictures. So basically it's saying, okay, I'm going to go ahead and create a graphic of what these particular customers like to get. So I have customers who love to purchase cars. They don't just like any car. They like Hondas. So I have to make sure that my data model represents a Honda because my primary customer base are Honda buyers. As far as metadata is concerned, that's the details about the data. So since my customers like to purchase Honda, I know that my customers from the metadata are typically between the ages of 25 and 35. They're between those ages because this is the ages that people tend to get married in this particular region where my metadata is being pulled from. Because of that, I know that my customers like to purchase Hondas. I know I sell Hondas, and I know I want to sell Hondas to this demographic of 25 to 35-year-olds who are newly married or about to get married. Therefore, I have to make sure I understand what that information is about them that will allow me to be able to put this within the metadata so that I can drill down to find exactly what I need to offer to these customers to get them to come in and buy my Honda. A data dictionary compiles all of the metadata about the data elements in the data model. So a data dictionary has within it for any companies, we're talking about Hondas, and this person sells Hondas, or this company sells Hondas, and their demographic is the 25 to 35-year-olds. They have to understand, okay, these are 25 to 35-year-olds who are getting married, starting families. They come from a variety of ethnic backgrounds, and we have to make sure that we respect that and understand that and be able to provide advertising that will meet those different requirements, allowing us to be able to sell more Hondas. So, storing data and data elements in entities and attributes. So when we think about an entity, every single database has entity and attributes and records. And they have to have that to be able to store the data efficiently. Now, databases can have different types of data. They can have structured data and unstructured data. Right now we're going to be talking about structured data. Structured data allows us to be able to say exactly what it is a person has by saying exactly what it is they are as their entity. So for instance, the person. The person, we're going to say Juan Gonzalez is the person. That's his first and last name. We have them listed once in our database. As the attributes, we're going to say Juan Gonzalez is 27. He is newly married to Anna Gonzalez. She is 24. So we have those attributes listed into fields and columns within our database. As far as the records, it's a collection of related data. So not only do we have Juan Gonzalez's first name and last name, we have his wife's first name and last name. We have both their ages. Not only that, we have exactly where they live and where they went to college. So they live in Hialeah, Florida. They went to college at Florida International University, both of them. We also have where they work, how much money they make, and their credit score, so that we know if we can sell them a Honda, and if we can sell them a Honda, what type of Honda, what year Honda, and what features within that Honda they can afford. So when we talk about databases, we have to talk about being able to connect the dots. So when you connect the dots, when you have a relational database, you have your records, you have your fields, you have your attributes, but you also have what they call keys. And the keys are your unique identifiers within any given table in a database. So your primary key is a field that uniquely identifies any given entity within the table. So the unique identifier here is Juan. His unique identifier is not his first name, but his social security number. We have that. The form key, which is a primary key of one table that appears in an attribute in another table. So because we have his unique identifier, which is his social security number, that is the primary key that it connects to the form key that links to his wife's first and last name, because they are married now, so they are uniquely identified. This primary key and this foreign key allows for these two relationships to be connected, which works well within a database. So, using a relational database for business advantages, there are, as you can see in this diagram, unique benefits. So, within those unique benefits, we have increased flexibility. So that's increased flexibility for the company. They have flexibility in certain areas if they not only want to sell Juan his first Honda, but they want to be able to sell Juan his second Honda, which has now went from a sedan to a minivan because him and his wife have started a family. So they are increasing their flexibility to be able to give new products to Juan. There's also increased scalability and performance. This allows for if there are multiple Juans with the same first and last name, but different primary key because the social security numbers are different, allowing for that scalability to happen and for the ability for the company to say, okay, Juan 1 needs a minivan because he now started a family, but Juan 2 has not gotten married yet, so there he may want a Honda 2-door coupe, something like that. And so then we have to look, okay, is there a redundancy in information? Can we reduce some of this information here so we're not trying to sell Juan 1 the same minivan that he already has? So you have to make sure that you're not duplicating efforts. Also, we have within here increased information integrity and increased information security. So you have to make sure, since Juan's giving the dealer or the finance company his information, like his social security number, to put in the database, he has to make sure that his information is protected and secure, and that the integrity of his social security number will not be compromised by doing business with this particular Honda dealership. So when we talk about databases, we have to talk about, can a database be scalable? Can it have a good amount of performance? Or will it be stagnant? We never want anything to be stagnant because that means it cannot adapt to change. That means it's always going to be the same and never ever change. And change, agility, adaptability, and flexibility are important to any type of business function, especially when it comes to data. So we need databases to be able to perform well. We need to be able to have the scalability that allows it to increase with demand or decrease with demand. We need to be able to have performance to see that it can work quickly when the demand for the product rises because the Super Bowl is on, the commercial came on for those Hondas, and boom, you want to get it right then and there. We have to be able to have that scalability and performance. We also need to be able to ensure information redundancy. The fact that we are not storing the same information in the same place with the same unique identifier. Every single person who's interested in a Honda has to have a unique identifier, hence a social security number. So driving websites, data can drive websites. So for instance, when I talked about the Super Bowl with a Honda, we're looking here at a particular web page that's talking about maybe these are old school flip phones. That's what it looks like. But let's say this was a Honda, and we're trying to sell our Honda online by selling the features of the Honda. What you see to the right that says to database, that is what a relational database would look like when it's built out into kind of like a flow chart. This isn't exactly a flow chart, but this is definitely a relational database, and that's what it will look like on paper. Within a software such as Oracle or DB2 or Microsoft, whatever relational database you're using, you're going to have your unique identifier, you're going to have your fields, you're going to have your attributes, you're going to have your primary key, you're going to have all these things listed within that database. Underneath you see 3, which is the pivot table. Now the database is something that developers really understand, but the pivot table is what the salespeople will understand. The pivot table is an Excel spreadsheet that puts what's in that relational database into a easy to read Excel spreadsheet that allows for the salesperson to be able to share with the client exactly the features that are listed within that Honda. So you can say, okay, well, you're going to pay this much to get Boss speakers. You're going to pay this much to get an upgrade to your Bluetooth. You're going to pay this much to get an anti-theft device. So all those are listed out in detail within that particular pivot table, allowing for the sales rep to be able to share with the customer exactly what features they would get in their brand new Honda and how much each feature will cost. So we move forward and we say, okay, what are the business benefits of having not just a relational database, but an actual data warehouse? So a data warehouse is where lots of information is being stored about a lot of different items or a lot of different people. It allows for the ability for day-to-day operations to happen for any organization, but for the data that is needed at that point in time to be accessed from that data warehouse. In addition, we have to think about performing business analysis using data marts. Therefore, we have to understand what extraction, transformation, and loading is, ETL. Every big major technology company has an ETL platform. IBM has one, Oracle has one, Microsoft has one, Tata has one. All the huge, large, global companies that deal with data on a regular basis have some sort of ETL software for their clients. And what this is a process that extracts information from both the internal and external databases of any given company, allowing for information to be transformed at any given moment, which will allow for the company to be able to grow and be able to meet customer demands. A data mart, contains a subset of data that is stored within any given data warehouse. So here you see a big giant data mart. Well, you see the nice pretty graphic. It looks totally different when you actually see the machines. But in the middle here we have a data warehouse, and this is for the data warehouse model. Within that data warehouse, that big giant, beige column, it's showing you within there you can have from an organization, you can have marketing, inventory, sales, billing, information about your competitors, information about your industry, all the information needed to be able to see your clientele, promotional material, and even stock market analysis if you're being traded on a stock market. You have within that the ETL, those are those gray arrows from your left-hand side that has within the internal databases at top, and at the bottom it has the external databases. Each database contains what's necessary for you to be able to do business with your client. When you move over, you see that once that information goes into the data warehouse, it's filtered. When it's filtered, it's extracted out into the necessary units that it needs to go to, whether it's marketing, whether it's inventory, or whether it's exploring and mining that data to be able to gain more information. So once you have that data, you have to be able to cleanse and scrub that data. Cleansing and scrubbing the data is nothing but a process to be able to find any imperfections, any information that's incomplete or inconsistent, to be able to change that information. Hence the power of big data analytics. Now, at some point, I'm sure you've all probably heard of big data. It's called big data now because everything we do is being stored in a database. Every time you take a Snapchat, every time you post something on Facebook, Instagram, Pinterest, LinkedIn, any of those social media sites, and even everything you do for business in general has to be stored somewhere. All that stuff is being stored in some data warehouse somewhere, which they call the cloud. Hence the evolution of big data. Because we have so much data coming in, all that data has to be filtered, shuffled through, and be able to be searched at a moment's notice. And that's where we see data mining, big data analytics, data visualization. There's all these different things that are happening worldwide. So this is just not an American kind of phenomenon. This is a global entity that is happening worldwide, where people are able to get to data, search through quickly, find what they need, and be able to do advertising campaigns, be able to pull data to find out who's doing something illegal, who's doing something terrorist related, who's doing something that's going to be the next big thing like Facebook or Snapchat or Twitter or whatever. You have that ability to do that with big data analytics. So big data analytics allows for data to be filtered and to be compiled both in a structured format or a unstructured format. Structured format means that there are defined limbs, defined types. You're able to easily put that information in. It doesn't include things like JPEGs or PDFs or any MP3s or any other type of video, picture, or digital format that's not easily plugged into a database. Unstructured is everything else that's not considered structured. So you have your videos, you have your tweets, you have your text messages, you have all these things that are considered more disruptive to the industry. Big data, as you can see, is a collection of large, complex data sets, including structured and unstructured data, which can be analyzed at any moment within a traditional database. So make sure that you understand that, because you may see this on the final. Please understand that midterm really covers Chapter 6. Now, the midterm is not long, but it's really important to understand relational databases. You only have one opportunity to do the midterm, so you should take your time, because remember, it's open for 10 days. So complete the midterm, do your Chapter 6 homework, which is the midterm, and make sure you work on your group project. I will see you in class.